Hey there, my little gecko-citos. I would like to welcome you to the wonderful world of simplifying variable expressions. Yes, just when you thought it couldn't get any better, now we're going to throw something at you that's even harder than what we've done before. Here's an example of what a variable expression looks like. Yeah, basically it looks like a math problem. It's got lots of numbers and it's got lots of letters in it. We haven't really looked at how we solve things like that, and today we're going to take the first step toward doing that. So first of all, we need to look at a couple of things. First of all, we've talked in math class about what an expression is. Well, an expression is a math problem. It can have numbers in it. We can have variables in it. We've got operations in it as well. Next, we need to look at what a variable is. Well, we know what those are. That's when these letters start showing up in math problems. It basically means they could equal any number. Which number? We don't need to know that yet. But before you can simplify a variable expression, we need to talk about a couple of things. There's a few words that we need to go over. So grab a piece of paper, grab a pencil. You'll need to write these down because these are important. First of all, we have these things called terms, okay? And those are basically the parts of an expression that are added together in our math problem, okay? Or that we are using in our math problem. For example, y right here would be a term. 8 could be a term. Negative 5y could be a term. Negative 3 or minus 3 could be a term. Any of those things could work or qualify as terms. All right? Those are any things that we're using in the expression. Okay, then we've got like terms. Okay? Like. You ever heard of that word? Exactly. It means the same or similar. So what we need to do is find some terms that are similar here. How about this? The y and the 8, are those similar? No. One's a variable, one is not. So I need to find things with variables and find things without variables. Well, I've got y and negative 5y right there. Those would be like terms. And then I've got 8 and negative 3. Those would be like terms. Okay? Anything with a variable should be used with another digit with a variable. Any digits or integers by themselves would just go along with the other integers in the problem. Next, we've got coefficients, okay? Coefficients. Well, to help you remember what this word means, just look at the front half, co. Okay, can you think of when we've stuck co on the front end of a word? All right, it usually means with, or to participate with, or to do something with. So when we're looking for a coefficient, we're looking for some things that, or some numbers that cooperate with other things in the problem. Other terms. So right now, my 1 would be a coefficient because I've got 1y. Negative 5 would be a coefficient because the negative 5 is teamed up with the term or the variable y. Okay? The 8 and the negative 3 would not be coefficients because they're not grouped up with any variables. And last but not least, we have our constant terms. Those are the terms that aren't combined with any variables. They're by themselves. Can you figure out what they are? Yes, that would be the 8 and the negative 3. Those are the constant terms. We can't add variables to them. We can't take variables away from them. They are just integers all by themselves. 8 and negative 3. Okay, first of all, let's look at how we simplify an expression. Here's an example. 4n minus 7 minus n plus 9, okay? First of all, what I want to do is I want to rewrite all of this as a sum. So I would do that like this. I would make that equal to 4n plus negative 7 plus negative n plus 9. And the reason I do that is coming up right now. My next step, what I want to do is use the commutative property. That's right, I'm going to change the order of this problem. And what I'd like to do is I'd like to put like terms and add those together, and then I'd like the constant terms, I'd like to add those together. So first of all, let's rewrite the problem using the commutative property and combining the like terms. So that would look something like this. 4n plus negative n plus negative 7 plus 9, okay? And the reason I do that is because when I'm going on to my next step, I can see that I can work with these two now because they're both coefficients. I can work with these two because they're both constant terms, okay? I can't subtract a coefficient from a constant term because they don't match up. So next what I'm going to do is try and solve this problem. And, well, let's see what we can come up with. Well, I've got 4n plus negative n. That's the same as negative 1n. And if I go all the way back to my addition rules, I have different signs, but I take the number with the bigger absolute value, that's 4, and I subtract this away from it. 4 minus 1, gave the answer away, gives me 3n, okay? Plus, well, then I go on here. Well, I look at negative 7 plus 9. Again, these are different signs. I've got a negative plus a positive. This one has the higher absolute value, so I subtract here. That's like saying 9 minus 7 gives me 2. There's your answer, 3n plus 2. I've simplified the expression, okay? Tonight I'd like you to try this example right down here. 3x plus 2 plus 5x. Give it a shot. Sometimes we have an expression that has parentheses. I've got 2 times x minus 4 plus 9x plus 1. Okay? Well, first of all, what I need to do is I need to use the distributive property. Again, that's where I pass a number through the parentheses. So we're going to take the 2 and we're going to distribute it through here and here. Let's see what we get. 2 times x gives me 2x. 2 times 4, or 2 times negative 4, give me negative 8. Okay? So, and then I can't do any more with the distributive property in this problem. So then I've got 9x plus 1. Forgive me if these numbers get a little goofy looking. It's hard writing with this stylus. Okay, now what did we do first on the last problem? Anybody remember? Well, we want to group up our like terms. So I want to put everything together that is alike. Let's see how that would look. Let's see, here's my coefficients. I'll start with 2x plus 9x. I'm just using the symbol that's right in front of the digit here. And then I've got minus 8 plus 1. Okay, so what we've done is we've matched up our coefficients here, and we put our constant terms over here. And now we can work on some solving. We can combine the terms. 2x plus 9x, well, 2 plus 9 is 11, and then I've just got x. It's not 2 x's, it's just x, because, well, x could be any number. Minus 8 plus 1. So let's see, we're looking at that like it's a negative 8. Well, anytime I have different symbols, this has got the bigger absolute value, so I know the number will be negative, so we would subtract. And then 8 minus 1 is 7. So my answer would be 11x, take away 7. What I'd like you to do tonight is try this problem right here. 3k minus 8 times k plus 2. It'll give you some practice with the distributive property, the commutative property, and working with like terms. Okay, finally, what I'd like you to do tonight, there's 3 problems. Identify the terms, the coefficients, the like terms, and the constant terms. You only need to do that on one of these problems. I don't care which one you may choose. However, you have to simplify all 3 of these expressions. So leave a little bit of space on your paper. Don't be afraid to make a couple of mistakes. Good luck tonight. Bring your papers tomorrow and we'll see how you do. See ya.